Section 13.3, Metrics and Monitoring with Spring Boot Actuator, Prometheus, and Grafana. To properly monitor, manage, and troubleshoot an application running in production, we need to be able to answer questions like, how much CPU and RAM is the application consuming? How many threads are used over time? And, what's the rate of failing requests? Event logs and health probes can't help us answer those questions. We need something more. We need more data. Metrics are numeric data about the application, measured and aggregated in regular time intervals. We use metrics to track the occurrence of an event, such as an HTTP request being received, count items, such as the number of allocated JVM threads, measure the time taken to perform a task, such as the latency of a database query, or get the current value of a resource, such as current CPU and RAM consumption. This is all valuable information for understanding why an application behaves in a certain way. You can monitor metrics and set alerts or notifications for them. Spring Boot Actuator collects application metrics out of the box by leveraging the Micrometer library, micrometer.io. Micrometer contains instrumentation code for collecting valuable metrics from common components in a JVM-based application. It provides a vendor-neutral facade so that you can export the metrics collected from Micrometer using different formats, such as Prometheus, OpenMetrics, Humio, Datadog, and VMware, Tanzu Observability. Just as SLF4J provides a vendor-neutral facade for logging libraries, Micrometer does the same for metrics exporters. On top of the default Micrometer instrumentation libraries that are configured by Spring Boot, you can import additional instrumentation to collect metrics from specific libraries like Resilience4J or even define your own without vendor lock-in. The most common format for exporting metrics is the one used by Prometheus, which is an open-source systems monitoring and alerting toolkit, Prometheus.io. Just as Loki aggregates and stores event logs, Prometheus does the same with metrics. In this section, you'll see how to configure metrics in Spring Boot. Then you'll use Prometheus to aggregate metrics and Grafana to visualize them in dashboards. Section 13.3.1, Configuring Metrics with Spring Boot Actuator and Micrometer. Spring Boot Actuator auto-configures Micrometer out of the box to collect metrics about a Java application. One way of exposing such metrics is by enabling the /actuator/metrics HTTP endpoint implemented by Actuator. Let's see how to do that. In your catalog service project, catalog service, update the application.yml file to expose the metrics endpoint via HTTP.
Listing 13.12, Exposing the metrics actuator endpoint.
Ensure the backing services required by catalog service are up and running with the following command.
See this code?
Then run the application, /gradle wbootrun, and call the /actuator/metrics endpoint.
See this code.
The result is a collection of metrics you can further explore by adding the name of a metric to the endpoint, for example, /actuator/metrics/jvm.memory.used. Micrometer provides the instrumentation to generate those metrics, but you might want to export them in a different format. After deciding which monitoring solution you'd like to use to collect and store the metrics, you'll need to add a specific dependency on that tool. In the Grafana observability stack, that tool is Prometheus. In the catalog service project, catalog service, update the build.gradle file with a dependency on the Micrometer library that provides integration with Prometheus. Remember to refresh or re-import the Gradle dependencies after the new addition.
Listing 13.13, Adding dependency for Micrometer Prometheus.
Then update the application.yml file to expose the Prometheus actuator endpoint via HTTP. You can also remove the more generic metrics endpoint since we're not going to use it anymore.
Listing 13.14, Exposing the Prometheus actuator endpoint.
The default strategy used by Prometheus is pull-based, meaning that a Prometheus instance scrapes, pulls, metrics in regular time intervals from the application via a dedicated endpoint, which is /actuator/Prometheus in the Spring Boot scenario. Rerun the application, /gradle wbootrun, and call the Prometheus endpoint to check the result.
See this code?
The result is the same collection of metrics you got from the metrics endpoint, but this time they are exported using a format understood by Prometheus. The following snippet shows an extract of the complete response, highlighting metrics related to the current number of threads.
See this code?
This format is based on plain text and is called Prometheus Exposition Format. Given the wide adoption of Prometheus for generating and exporting metrics, this format has been polished and standardized in OpenMetrics, openmetrics.io, a CNCF incubating project. Spring Boot supports both the original Prometheus format, the default behavior, and OpenMetrics, depending on the accept header of the HTTP request. If you'd like to get metrics according to the OpenMetrics format, you need to ask for it explicitly.
See this code?
When you're done analyzing the Prometheus metrics, stop the application, Control-C, and all the containers, Docker Compose down. Note: you might encounter scenarios where you need to collect metrics from ephemeral applications or batch jobs that don't run long enough to be pulled. In that case, Spring Boot lets you adopt a push-based strategy so that the application itself sends metrics to the Prometheus server. The official documentation explains how to configure such behavior. See this link. Spring Boot Actuator relies on the micrometer instrumentation and provides auto-configuration to generate metrics for various technologies you might use in your applications: JVM, loggers, Spring MVC, Spring WebFlux, REST template, web client, data sources, Hibernate, Spring Data, RabbitMQ, and more. When Spring Cloud Gateway is in the class path, as in the case of Edge Service, additional metrics are exported regarding the gateway routes. Some libraries, like Resilience4j, contribute dedicated micrometer instrumentation through specific dependencies to register additional metrics. Open the build.gradle file in the Edge Service project, Edge Service, and add the following dependency to include micrometer instrumentation for Resilience4j. Remember to refresh or re-import the Gradle dependencies after the new addition.
Listing 13.15. Adding dependency for micrometer Resilience4j.
Now that we've configured Spring Boot to expose metrics, let's see how we can configure Prometheus to scrape them and Grafana to visualize them. Section 13.3.2. Monitoring metrics with Prometheus and Grafana. Like Loki, Prometheus collects and stores metrics. It even provides a GUI to visualize them and to define alarms, but we'll use Grafana for that since it's a more comprehensive tool. Metrics are stored as time series data, containing the timestamp when they were registered and, optionally, labels. In Prometheus, labels are key value pairs that add more information to the metric being recorded. For example, a metric registering the number of threads used by the application could be enhanced with labels qualifying the state of the threads, such as blocked, waiting, or idle. Labels help aggregate and query metrics. Micrometer provides the concept of tags, which are equivalent to Prometheus's labels. In Spring Boot, you can leverage configuration properties to define common labels for all the metrics produced by an application. For example, it's useful to add an application label that tags each metric with the name of the application that produces it. Open the Catalog Service project, Catalog Service, go to the application.yml file and define a micrometer tag with the application's name, which will result in a label that's applied to all metrics. Since the application name is already defined in the spring.application.name property, let's reuse that instead of duplicating the value.
Listing 13.16. Tagging all metrics with the application name.
With this change, all metrics will have an application label with the application name, which is very useful when querying metrics and building dashboards to visualize them in Grafana.
See this code.
You have already encountered Grafana when working with logs. Just as you browsed logs using Loki as a data source for Grafana, you can query metrics using Prometheus as a data source. Furthermore, you can use the metrics stored by Prometheus to define dashboards, graphically visualize data, and set alarms or notifications when certain metrics return known critical values. For example, when the rate of failing HTTP requests per minute goes above a certain threshold, you might want to get an alarm or a notification so you can act on it. Figure 13.5 illustrates the monitoring architecture.
Figure 13.5. Monitoring architecture for cloud-native applications based on the Grafana stack.
In your Polar deployment project, Polar deployment, update the Docker Compose configuration, docker/dockercompose.yml, to include Prometheus. Grafana is already configured to use Prometheus as a data source in the configuration files you imported into your project earlier from Chapter 13/13end/Polar deployment/docker/observability.
Listing 13.17. Defining Prometheus container for collecting metrics.
Unlike Loki, we don't need a dedicated component to collect metrics from the applications. The Prometheus server container can both collect and store metrics. Next, open a terminal window, navigate to the folder where you keep your Docker Compose file, Polar deployment/docker, and run the complete monitoring stack with the following command.
See this code?
The Prometheus container is configured to pull metrics every 2 seconds from all the Spring Boot applications in Polar Bookshop when they run as containers. Package catalog service as a container image, /gradle w boot build image, and run it from Docker Compose.
See this code?
Send a few requests to catalog service, http 9001 books, and then open a browser window and go to Grafana at localhost 3000, user, password. In the Explore section, you can query metrics like you browsed logs. Choose Prometheus as the data source. Select last 5 minutes from the time drop-down menu, and query the metrics related to the JVM memory used by the application as follows, figure 13.6.
See this code? Figure 13.6. In Grafana, you can browse and query metrics aggregated and stored by Prometheus.
The metrics data can be used to draw dashboards for monitoring different application aspects. Select Dashboards, manage from the left menu, and explore the dashboards I have included in Grafana, grouped within the application folder. For example, open the JVM dashboard, figure 13.7. It visualizes different metrics regarding the JVM where Spring Boot applications run, such as CPU usage, heap memory, non-heap memory, garbage collections, and threads.
Figure 13.7. In Grafana, dashboards can be used to visualize Prometheus metrics.
On the Dashboards page, explore the other dashboards I have configured to get more visibility into the Polar Bookshop applications. Each dashboard is enhanced with additional information on its goal and how to use it. When you're done checking the application metrics in Grafana, stop all the containers, Docker Compose down. Section 13.3.3, Configuring Prometheus Metrics in Kubernetes. When running applications in Kubernetes, we can use dedicated annotations to mark which containers the Prometheus server should scrape and inform it about the HTTP endpoint and port number to call. You'll have the chance to test this setup later in the book, where we'll deploy the full Grafana observability stack in a production Kubernetes cluster. For now, let's prepare the deployment manifests for all of the Spring Boot applications in Polar Bookshop. For example, the following listing shows how to change the catalog service manifest, catalog service/k8s/deployment.yml.
Listing 13.18. Annotating catalog service for Prometheus metrics scraping.
Annotations in Kubernetes manifests should be of type string, which is why quotes are needed in the case of values that could be mistakenly parsed as numbers or Boolean. Go ahead and configure metrics in Prometheus for all the remaining applications in the Polar Bookshop system, including the configuration for the Kubernetes manifests. As a reference, you can look at the source code repository accompanying this book, Chapter 13/13end. The next section will cover another type of telemetry we need in order to monitor applications and make them observable, traces.